Coming back, so our I'll just repeat things. So this is E3T2 digital communications, and the books that we will follow are mainly the book by Prokes and Salehi, Communication Systems Engineering. We will also refer to Digital Communication by Prokes and Salehi and Digital Communication Systems Simon Hakin. And there is this book by Robert Gallagher, Principles of Digital Communication, that we would touch upon here and there. This is quite a rigorous book, and last year I taught from this, your senior batch, and the majority didn't like that. That was because for them the course became too mathematical then. So we won't make this course too mathematical, or we won't go into measures and Lebesgue integration and all that stuff. We'll follow more of a signal processing approach to digital communication. So like last time, we have divided this course into modules. So the first module is source coding, which is where we pick off from analog to digital conversion. Then digital modulation and data detection under additive wide Gaussian noise. Then communication through band limited channels, synchronization, error control coding, and finally wireless communication. So in general, uh, source coding, digital modulation, and data detection under AWGN, and communication through band limited channels. These are mainstays of digital communication courses. And people then pick and choose from synchronization, error control coding, or wireless communications depending on the time available. So we will do the same. We will first focus on source coding, digital modulation, and data detection under AWGN, and communication through band limited channels. Following this, uh, we will spend some time, maybe 1 or 2 lectures on synchronization. And then if time permits, we'll pick and choose out of error control coding and wireless communications, whichever is preferable at that point of time. And this is the scoring chart. So the project this time is again will be either a video or a writing project, something like that you will have to submit at the end of the semester. More details will come at the end, because since you have a separate lab and that is coding lab, and people are choosing to do a coding project over there, I won't be giving out a coding project. Make sense?
Yes, sir.
Yes, sir.
Yeah, and also I won't be grading your theory based on the lab, or grading the theory based on the grading the lab based on theory. Those are these are two separate courses, or these are two separate courses. You won't be repeating anything, but one won't overflow into the other. Fine. So this scoring scheme is okay. This is mainly the last semester's scoring scheme, just that the project instead of 10% weightage now has 15% weightage. And quizzes should have an extra Z. So any comments, suggestions over here?
Sir,
Yeah.
is it possible to have 40% weightage for quizzes and 25% weightage for the project?
Uh, and it won't be a coding project. So you want 25% on a video or on a story written assignment, then I won't be too enthusiastic about it.
Okay, sir. Okay, sir.
Okay, so this This you have seen, right? Actually, let
Yes,
me
sir.
choose this. Yeah, let me correct this right now. Just a second. Just give me a minute. This you know from previous semester. So this won't change, and this subtitle is from when I taught embedded systems. So I just copied that slide that carried forward. So this is the schedule for the quizzes.
Sir, we have 5:30 to 7 Monday, every Monday information theory lecture.
Ah, ouch. So when do you want the quizzes then?
Sir, we have these lectures on Monday and Tuesday. Apart from them, it's okay, I guess.
So
Yes,
Fridays.
yes,
Sir,
sir.
we also have the minor course, so that seeps in.
So
Sir,
when?
Wednesday, Thursday, Friday after 6 p.m. I think minor is from 5 to 6. So after
Yes, sir.
6.
We have open elective from 6 to 8.
Eh,
Saturdays will be good, I think.
Okay, then
Yes,
we'll
sir,
have to move
Saturdays are
this to
fine, I think.
Saturdays. Okay. So then 23. This goes to 6th February. This goes to 20th February. 6th March. 20th March. 3rd April. 17th April. Fine. When do you want these? We can also decide on the time now.
Saturday evenings?
Oh, just a second. Are not able to see that. Yeah. 5 p.m. is
Yeah,
fine.
fine with me.
Okay.
yes, sir.
So let's have a quick poll. All those in favor of Saturday 5 p.m. Okay, where is it? Here it is. Yeah. So all those in favor of Saturday 5 p.m. please raise your hands. '23, '24. So 25, 26, 29, 30, 31, 32, 33, 36, 37, 39, sorry, 40, 42. And if we have two more, we'll have an absolute majority. We have absolute majority. Fine. So out of 90 people, 45 people agree, and means out of how many? Around 60 people, 45 people have agreed. So out of the 60, around 60 people present. So that I believe is a fair number. So those opposed to Saturday 5 p.m. what other time slot would you propose? Fine. So quiz is out of the way. You know the format for Viva. So this is fine.
Yes, sir.
Great. Any other comments regarding this? Okay. Since we have no more comments,
Sir,
yeah,
uh, the quizzes, can it be kept 5 out of 6? Like one quiz can be replacing the can one better school quiz can replace the other poor
there are
quiz.
1, 2, 3, 7, 7. There are 7.
Yes, sir.
So 5 out of
6 out
7.
of 7.
5
Okay,
out of 7.
fine.
Okay, sir. Thank you,
Happy?
sir. Yes, sir.
Okay, so let me write this here. So uh, I will let me make this formal here. So insert text box, best 5 scores out of the total 7. Fine.
Thank you, sir.
Yeah. So Viva, again, the same marathon format. Since we have smaller number of students this time, so I believe we should be able to finish in how many days? So Saturday, half of Sunday, 1.5 day, Monday, Tuesday, Wednesday. So we have 4.5 days. So based on previous experience, we should be able to finish this for 90 students. We can do this in less time as well, but let's keep time on our hands. So so yeah. So this was about the administrative structure of the course. Any questions or comments?
No, sir.
Okay, great. So let us, we have talked about the digital communication channel in the previous course. So what I'll do is I'll take a 2-minute break. I'll be back and then we can, I'll move to the laptop. I'll move to my writing laptop and then we can start discussing these things. I'll be back in a minute. So stop sharing. two people have raised hands. Let's address those. So Chandan, Prabjot, first Chandan because I saw his name first.
It was a mistake, sir. Sorry.
Okay, Prabjot. Okay, it seems that he also made a mistake. Anyway, so coming to, so these are the books. These will be available in the class notes. So these are the books. So the class notes will be made available as usual via OneNote, and the videos will also be uploaded after the class. So this is a basic digital communication system. We discussed this in the previous course as well, but for the sake of completeness, let us revisit this. So you have an information source. So can be speech, image, text, anything. Right. So the information can be speech, text, image, anything. In order to and this is an analog source, can take any value for any point of time. Fine. Then the second step is analog to digital conversion. So for digital, or rather I should write it here, for digital communication, we need to have digital information, right? That's why we do analog to digital conversion. Then once we have digital information, we get rid of redundancy. That is called source coding, or in more slightly more precise terms, we encode the information from the source to make more or make the transmission more efficient. More. As an example of source, or what source coding is, as an example, and there's this TV series that I used to watch, The Thin Blue Line, and that has a famous dialogue. The police inspector says that we will start the raid sorry. Huh. We will start the raid led by me in person. That is grim at 2100 hours PM in the evening. So this is supposed to be a funny line. So can you tell me what is the problem with this sentence?
Redundancy.
A lot of redundancy. So uh, led by me in person, that is Inspector Grim. You can say, you could have said led by. So what you could have done, what he could have done is this. And then PM in the evening. These are also not required. Fine. So because of this, there is 2100 hours PM. Sorry, the actual dialogue was 2100 hours, 2100 hours o'clock PM in the evening. That show is supposed to be a sitcom. Anyway, so so this and so there is redundancy. So and when we create data, there is a or in practical information sources, there is a lot of redundancy. For example, the English language, due to its another point of source coding is that the English language, due to its structure or due to the different pronunciations, is quite redundant. For example, I don't know whether I have asked this to you, but let's try this. So how do you pronounce this word? Anyone? Okay.
Goti.
Yeah. Let's dissect this one by one. So it's pronunciation. So let's look at this. So yeah. Now what is this? How do you pronounce this word?
Fish.
Fish. Yeah. So this is, yeah. So there is, so this is just an example of redundancy, but in another case, or practically, if you want to characterize redundancy in language or in practical signals, say suppose you take a picture of me and if you see the, so there will be a lot of pixels. So suppose you take a, so my phone camera has how many pixels? 48 megapixels. 48 megapixels means that it will, there will be 48 million pixels in the image that it captures, or 12 million pixels if you downsample appropriately. We'll discuss downsampling in that DSP lab. So if there is, if you downsample appropriately, or so there are 12 million pixels of, say, if I am as tall as I am across, or as I'm as fat as I am tall, so that would be 170 centimeters. So approximately I would be 3 meters square. So if someone takes a picture of me, so that would nicely fit into 3 meters square. So 3 square meters. So 3 square meters means that there are 6. So, or rather, this is 3. Okay. So this guy is misbehaving. Oh, and one node crashed. So yeah. So 3 meters square, or rather I would write 3 into 10 to power 6 millimeters squared is 12 into 10 to power 6 pixels, or 4 pixels per square millimeter. Fine. 4 pixels per square millimeter. And how much is 1 square millimeter? Just minuscule, isn't it?
Yes, sir.
So, uh, and 4 pixels in that. So if someone, so a patch of my forehead would actually contain hundreds of pixels, if not thousands. So, and the color everywhere will be brownish, or if you take a picture and even my hair would contain thousands of pixels, hundreds of pixels, and all those pixels would be black, some shade of black. I don't have that much gray on my head as of now that it would be black, salt and pepper, or there would be a lot of change, but that would be more or less uniformly black. So, and for each pixel, you are actually spending 32 bits. So each pixel is actually 32 bits. So you are actually, if you see this, you are wasting a lot of information. If you try to transmit this image as a bitmap, So what we call a raw image. So in a raw image, this will be there. 32 bits per pixel, and the two adjacent or pixels next to each other will be quite highly correlated. So this is wasteful. So we need to do source coding in order to make better use of the memory and better use of communication resources. That's why source coding is important. So source coding is basically, or in other words, I can say that source coding is basically compression. Compression comes in two varieties: lossy, lossless. So lossy compression is where you say that, okay, I am ready to lose some information, but I want smaller sizes. So examples are MP3, JPEG, most, even MP4 video. Because lossless compression, there is something called Huffman coding. So these topics I delegate to your compulsory elective. You will know about these in that course. For MP3, so what we will do is in this course we'll talk about lossy audio compression. And you will implement this we will implement lossy audio compression in the lab. Fine. So this is source coding. Then after source coding, the next block. So source coding is basically you compress the information. Then the next part is channel coding, which means so adding now source coding. I have compressed or I have made my message as crisp as possible. Now I want this message to be communicated over a communication channel. So, but the communication channel is noisy. So since the communication channel is noisy, the message that I receive may be in error. So in order to mitigate that error, we do what is known as channel coding. And so if you uh, again considering a practical example of channel coding, suppose you want to call someone from within the department. You know that I hope you remember how good cell phone signals are within the department, right?
Yes,
Yes,
sir.
sir.
Yeah, good. So suppose you want to call someone from within the department. So one good or one common thing is that I call someone and I say hello, and they say hello, 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 hello. We have done this, right? Biswa Kalyan Rath has made fun of this as well, as if the Vodafone and Jio people are waiting to hear your different tones of hello. Anyway, so but what we do is that okay, that, suppose I know that someone takes attendance on paper, and I am feeling too lazy for a class, so I'll call my friend up and say, यार अगर वो ना देखे तो अटेंडेंस लगा देना. क्या? अगर वो आज पेपर पे अटेंडेंस ले, अटेंडेंस लगा देना. क्या? अटेंडेंस लगा देना. क्या? प्रॉक्सी. This is what happens, right?
Yes,
Yes,
sir.
sir. Yes, sir.
Yes. So you end up repeating the word proxy again and again because that's the key word. Everything else is so basically attendance laga dena is redundant. You, as the channel worsens, you do source coding and reduce it to one word proxy, and then you repeat proxy again and again to get the message through. So that repeating the word proxy again and again is channel coding. You are communicating over a noisy channel and you are repeating the message so that it gets through. So in source coding, you remove redundancy, and in channel coding, you add controlled redundancy so that the message gets through over a noisy channel. The next part is digital modulation. Where we transmit digital signals over an analog channel. Digital modulation is how we, since we now have digital signals and we have repeatedly said that digital signals are nothing but a sequence of zeros and ones or a stream of bits. So, but the physical channel, the channel over which we are communicating, all of these are analog channels. They carry current, they talk in terms of electromagnetic waves, right? So we have to have physical signals to carry these messages. So digital modulation is again, we will revisit some ideas from the principles of communication course, that how to send digital signals over an analog channel. And then we characterize the channel, which is noise plus a lot more. So the digital communication channel is much more than noise, or the problems caused by digital communication channels are much more than noise. And then obviously we unpack. So basically once we receive the signal, we undo all the operations that we have done. So we demodulate the digital signal, we do channel decoding, we do source decoding, we do digital to analog conversion, and we get the information back. Make sense?
Yes, sir.
Yes, sir.
Excellent. So this is the digital communication process in a nutshell. So now what we will do is we will take up source coding. And we simply start the case where we have sampled a highly correlated random process. We have sampled a highly correlated random process. So speech, for example, speech acts or sampled speech acts as a random process that is Whiteson stationary for durations close to 30 milliseconds. Fine. So should I jump into the math today, or should we start with the math tomorrow?
Sir, tomorrow would be better, I guess.
Yes. Okay, great. So we start with the source coding tomorrow. Fine. So that would be all for today then. Thank you. Have a nice day.
Thank you, sir.
Bye.
Bye, sir.
Bye, sir.
Bye, sir.
Bye.